Hi everyone, this is coming to you from Education for All. We're on trigonometry and modeling. We got two questions here to solve. We completed the first one, which is sine into x plus pi over 4. We are asked to use addition formulae, to write these functions we have here as a single trigonometric function in the form sine into x plus or minus theta or cos into x or minus theta. So you see, you can have two answers. You can have two answers. You can have the sine answer. You can also have the cosine answer for one question. If you want to use the sine formula here, you can have, we have already solved this one, we'll arrive at this. If you use the cosine side, you will get another answer that will tell you this same thing is equal to the cosine of x minus pi all over 4. But the method is the same. Just the formula you use here changes. The method is the same. So any of the two answers is correct, or you give both answers. I don't want to solve the same thing over and over. So the same thing for the second one. You can have two answers as well. So let's see what this second one says. It says 1/2 into sine x plus root 3 cos x. So again, let's distribute this one. We'll distribute the 1/2. So this is going to give us the sine of x. I'm putting a point. This means multiplication. You're multiplying by 1/2 plus root 3 all over 2 cos of x multiplied by root 3 all over 2. You know, the 2 will come under root 3 here. So this is what we got here. So again, what are we looking at? We have cos something plus sine something. So we are looking at something very similar to this. It's very similar to this. So now, because when you look at this, what gives you this? When you look at your formula, that's why they ask you to use your addition formula. So what gives you this? You are going to get sine A cos B plus cos A sine B. So it's this one. So the answer you get will be a sine. So sine into A plus B. That's all. So it means this is sine A cos B. So you now have cos B here. Cos B equals 1/2. And again, you have sine A cos B plus cos A sine B. And your sine B here is equals root 3 all over 2. That's all. That's all you need. So then, but you want B, you want the angle B. So what is B? B is the inverse cosine of 1/2. And what is here again? You want B. So B here for this side is the inverse sine of root 3 all over 2. All you need to do now is to find the value of B sine, the value for B when you use the sine identity, and the value of B here when you use the cos identity. That's all you need. So when you look at your exact trig functions, how do you get the exact trig functions? I'll show you something. Here we are looking at 1/2. if you have a triangle like this, A, B, C, so you know that all the angles are 60 degrees each. So I want to give 2 units to each side. This is an equilateral triangle, right? I want to give 2 units on each side of this triangle. But I want something much more than this. So I want to divide this triangle into 2 triangles. I cut it in the middle here, yeah? So now I have one triangle there and another triangle. It depends the one you take. So let's concentrate on that one there. So this was 60 degrees. 60, 60 makes 180. Now I divide this angle here. So this is going to remain 30 degrees. So this is still going to remain 60 degrees. So what is 30 degrees? When you convert 30 degrees to radians, what do you get? 30 degrees to radians. 6. 3, 6. So you get, when you convert 30 degrees to radians, you get pi all over 6. When you convert 60 degrees to radians, you get pi all over 3. You know how to do that conversion. That's something else. If you convert 60 degrees to radians, you know how to do that. The formula is straightforward. Right? So now, because I've divided this line through this perpendicular line, so instead of 2 units here, I'm going to have 1 unit here, 1 unit here left. So now what is this length? This line here, AN. I call here N. What is it? Use the marker. What is AN? Oh, sorry, CN. What is CN? According to Pythagoras theorem, this is the hypotenuse here. So it's 4 squared equals to 1 squared plus if this CN squared. So this is, sorry, 2 squared. I'm saying 4 squared. 2 squared. So this becomes now 4 minus 1 equals Cn. So this is 3 equals Cn squared. So I want Cn, not Cn squared. So this becomes 3 equals Cn. So this length here becomes root 3. Right? It becomes root 3. So now, let's see what we get. If I say sine of 30, I want sine 30 degrees. Sine 30 degrees, which is the same as sine pi over 6 radians. Pi over 6. What sine gives you? Sine gives you opposite all over the hypotenuse. The sine is opposite all over hypotenuse. And the opposite is 1. All over the hypotenuse is 2. So what is cos of pi all over 6? Cos of pi, cos is the adjacent all over the hypotenuse. And adjacent is, now our adjacent is root 3. All over the hypotenuse is 2. We don't want to go into tan. Yeah, because we are dealing with sine and cosine. So let's stop there. What about if you want cos 60? Cos 60 degrees. Cos 60 degrees, which is cos pi over 3. Now cos is adjacent all over hypotenuse, which is 1/2. So you want sine 60 degrees. Sine 60 degrees is pi over 3 in radians. So sine 60 degrees, sine 60 is opposite all over hypotenuse. Opposite, no. So cos 60, cos is adjacent. cosine, adjacent is 1, sine is opposite, which is root 3, all over hypotenuse is 2. So just by remembering this diagram, all those exact trig function values, you can easily work them out. This is what we have done here. In that case, now what gives us, we want sine, arc sine pi over 2. What gives us pi over 2? So yeah, root 3 over 2. Root 3 over 2. Sine root 3 over 2. Sine pi over 3 is equal to root 3 over 2. Yeah? Sine pi over 3 is equal to root 3 over 2. And cos 1/2. So cos pi over 3 give 1/2. So this one here, if we are changing it to be, so this will give us pi all over 3. And this one will give us pi over 3 as well. Pi all over 3. Yeah? B is equals to, and here again B is equals to this. So you get the angle to be pi over 3. So therefore, this question now becomes the sine of x plus pi over 3. That's what you get. Thank you for watching.